Hi everyone, thank you for joining me today. Today I am going to present about my text mining final project and my topic is AI based facial recognition in public spaces, one of the most talked about and controversial technologies in recent years. We are going to look at how people feel about this technology based on real world discussions, articles and reports. We will also explore how machine learning models helped surface interesting patterns and sentiments hidden in all the text. I will walk you through where the data came from, the methods used, and what I have learned, including the opportunities and challenges associated with the rapid expanding technology. Now, coming to the introduction, facial recognition technology identifies individuals by analyzing unique facial features using AI. It's increasingly used at airports, shopping malls, concerts, and even government spaces. On the surface, it promises security, speed, and convenience, but underneath, it raises deep concerns. How much privacy do we give up? Who is collecting your facial data? Are these systems fair and unbiased? This technology touches on some of the most sensitive human rights issues, making it essential to understand not just its technical capabilities but also its broader special implications. Our project exactly focuses on that interactions between innovation and civil rights. Now, what are the goals for our research? The goals of this project were clear. First, to predict sentiment, whether discussions about AI facial recognition lean positive or negative. Second, to discover key topics, concerns, and themes that arise when people talk about it. I hope that by using different machine learning techniques, I could not just classify opinion but also extract meaningful patterns from vast amount of text data. Policymakers, privacy advocates, technologists, and everyday citizens would all benefit from understanding where public sentiment stands today. It can inform better policy, more ethical production design, and more responsible innovation. Now coming to the data overview, the text data came from three main sources: News API, the Guardian's API, and the Hacker News discussions. I carefully targeted articles and conversation focused on AI privacy, surveillance, and facial recognition. This gave me a diverse, real world sample of media reports, expert opinions, and public discussions. By using APIs, I avoided bias from a single news outlet or platform. It was important to capture a wide variety of voices to truly understand the full range of opinions, from tech enthusiasts to privacy advocates to regular people simply worried about being monitored at the mall or workplace. As you know, raw data is messy, full of irrelevant characters, links, ads, and noisy formatting. To make it usable, I cleaned it carefully. I removed punctuations, special characters, URLs, and stop words. I also lemmatized the text, meaning I reduced words to their running root forms like running to run. After this pre-processing, I used TF-IDF vectorization to turn text into numeric features. This numeric matrix worked without this structure preparation. No model, whether simple or complex, could have found meaningful patterns in the chaotic original data. As you see in the slide, on the right side, you can see my raw text data. This is not the clean data. I clean the data after uh, I've got the data from the APIs. Now, to dig into the data, I applied a combination of unsupervised and supervised machine learning techniques. The first one is clustering. Clustering helped me to find natural groupings in the datasets without any pre-labeled categories. Using k-means, I found that three main clusters captured the bulk of discussions. The first one is around privacy concerns, the second one is around technology innovations, and the third one is about government regulation. Hierarchical clustering reinforced these groups and allowed me to explore deeper connections between articles. The insight here is that public conversation around facial recognition naturally fall into these three buckets, suggesting that any future debates or policies need to address all three areas if they want to be comprehensive. The second unsupervised model I used was association rule mining. ARM, it is typically used in market basket analysis, was applied here to find strong word pairings in text. Words like facial and recognition obviously appear together often, but I also found connections like privacy and security and surveillance and government. These associations hint at underlying narratives. For example, the discussions about facial recognitions are almost inseparable from concerns about surveillance and loss of privacy. ARM offered a subtle but powerful look into how concepts are tied together in public consciousness. The third model I used was LDA topic modeling. With LDA topic modeling, I extracted five major topics from the datasets. These include AI development, government surveillance, digital security, privacy debates, and corporate use cases. Word clouds for each topic made interpretation easier, highlighting important keywords. One takeaway was how deeply intertwined facial recognition is with larger issues of AI ethics, not just simple technological advancements. Even when people weren't directly talking about facial recognition, themes of trust, power, and rights kept resurfacing, showing how broad and interconnected these discussions really are. Next, the first supervised machine learning model I've used was Navy Bayes. Navy Bayes served as my baseline model. It achieved an accuracy of about 49%. While it is not exceptionally high, it revealed important trends. Words like privacy, freedom, and surveillance were highly influential in classifying negative sentiment. This confirmed that concerns about privacy liberty are central to public opposition. It also showed that simple probabilistic models, even with basic assumptions like word independence, can still capture meaningful patterns when analyzing societal issues through text. The second supervised machine learning model I used was decision trees. Decision trees offer something very valuable interpretability. I could visually trace how the model decided if a text was positive or negative. I will show it in the next slide of images of my trees. It split data based on terms like company, work, and getting, showing that concerns about workplace surveillance and corporate data practices heavily influenced sentiment. Although the model accuracy was not very high, it is around 53%, its real value was in its explainability, making it easy to communicate the findings to a broad audience without technical jargon. Remember, our dataset sample is very small, so this is the reason why we are not getting high accuracies when applying machine learning models. This does not mean that these models are not giving any results, but the models are highly explainable and interpretable, giving great insights about the data. As I told you in previous slides, decision trees are easily identifying the negative text and positive text. These are example of two trees with max depth is equals to 3 and max depth is equals to 2, where it is classifying a word into a positive or negative. This helped me to identify a lot of patterns in the data. The third supervised machine learning model I've used was support vector machines. SVMs, especially using the polynomial kernel, achieved best performance with accuracy reaching 56.8%. My SVMs were able to find more complex, nonlinear boundaries between positive and negative sentiment. Visualizations of the decision boundaries were showed in the next slide. That public opinion is messy, not cleanly separated, but that with the right tools, I can still find meaningful divisions. This suggests that non-should flexible models are better suited for analyzing ethically loaded, emotionally complex topics like surveillance and AI ethics. I've used three different kernels for SVM model. As you can see, these are the decision boundaries where you can see that public opinion is not very much clear, but with the right tools we can able to separate the planes and we can still get the patterns of what public are trying uh, to think about surveillance and privacy. Next, the last model one I have used was one of the complex models, like it is neural networks. Neural networks also performed competitively, achieving around 55.8% accuracy. They were slightly better at detecting positive sentiment. However, overfitting was a challenge, as seen in the divergence between training and validation accuracy. This reinforces a critical lesson. More complex models don't always outperform simpler ones, especially when working with smaller or imbalanced dataset. Still, neural networks showed potential for learning deeper patterns in text, hinting at opportunities for future improvements using larger corpora or pre-trained language models. Now, let's put everything together. Machine learning models showed moderate success in predicting public sentiments about facial recognition. Clustering revealed major areas of concerns, privacy, technology, and regulation. ARM surfaced deep links between concepts like surveillance and freedom. Topic modeling showed us how facial recognition fits into bigger debates about AI and civil rights. Together, these techniques painted a rich, layered picture of public opinion that would be hard to achieve with mutual reading alone. Coming to the conclusion, the overachieving conclusion is that privacy concerns dominate the narrative. Public acceptance hinges heavily on transparency, consent, and fairness. Without clear regulations and ethics safeguards, facial recognition technologies risk fueling mistrust rather than security. Citizens demand more control over their data, and the technology's benefits must be clearly and fairly demonstrated to gain wider public support. This project highlights the urgent need for ethics to catch up with innovation. Now, what's the final message? Looking ahead, the focus must shift from just improving technical accuracy to improving social responsibility. We need stronger laws, better transparency, community involvement, and opt in rather than opt out systems. Advances in AI must come at cost of human rights. People aren't rejecting technology, they are rejecting systems that take away their agency. Future research should prioritize ethical design principles, user control, and equitable access to prevent deepening inequalities. In short, the future of facial recognition will depend not just on algorithms but on human values and human rights. Thank you for your attention. This concludes my presentation. I hope you now have a deeper understanding of the complex multi-dimensional conversation happening around AI based facial recognition today. Thank you for your time.